In the sheet, the second question I had doubt once you open this.
1 second, let me open it. Which set?
Set 2.
Set 2. 1 second.
Yeah.
So
Yeah.
first question I think you should be able to do, because this I'll just quickly go through all of the questions just for the
Yes.
quick reference. So the first
Okay.
question I think everybody should be able to do this,
Yeah.
because we already cover in the session itself how
Yes.
to
Yes.
find a
Yeah.
rotation count in a sorted array, right? Everybody?
Yeah. Yeah.
So first question was already done in the session. Second one is search an element in the sorted and the rotated array, right? Initially the array was sorted. Okay.
Mhm.
Initially the array was sorted and then it was rotated. So once you have
By some
rotated,
unknown.
yeah,
Yeah.
by some unknown number. So once you have
Hmm.
rotated and sorted array, it is no more sorted, right?
Yes.
So this is the condition that has been given to you, and then you have to search an element in this. You have to search an element in this array. Okay. If you go by brute force approach, you will go and check every element of this array and
Yeah.
see if the element is present in it, and it will give you a time complexity of O of n, right?
Mm-hmm.
But this question has some additional information that it was initially sorted, right?
Yeah.
And it has been rotated unknown number of times. So if
Yes.
you go and use this information, it will give you an additional insight so that you can search the element instead of in a linear time you should try to search in the log n time. Okay.
Mm-hmm.
Now forget this problem first. If you have been given a sorted array and if you have to search an element in that, how will you go for it in that case?
Yeah. Just I'll apply binary search
You will
and
apply
uh,
binary search, and the
yeah.
binary search will have a log n time complexity.
Yes.
Now,
Yes.
when an array was initially sorted and it is rotated an unknown number of times, right? How do we find that, how many times it got rotated? This is the first problem, right? We find the index of the smallest element, right?
Mm-hmm.
And how do we find this index of the smallest element? That also we find logarithmically using the modified binary search. We talked about that in that session, right? How do we find
Yeah.
the smallest element? We can do it by using a modified binary search, and that can be done again in the log of n time, right? Take the example of this first input 5 6 7 8 9 10 and then 1 2 3. Okay, once you find the index of the smallest element, you will see there are two parts of the array. There are two parts of the array. From the smallest element till the end, again it is a sorted, and from the starting till the largest element also it is a sorted array, right? So for example,
Mm.
5 10 is also sorted, and 1 2 3 is also sorted. So your array basically contains is being divided into the two parts, and each of the part is still sorted. Okay, so you
Mm.
can still apply binary search in this array because the array has two parts and both of the parts are sorted. So in these sorted parts of the array, you can still try to search in the logarithmic time complexity. Okay. So one simple state way is that you just divide the array into the two parts. First, try
Mm.
to search in a binary search way into the first part, and if you don't find, then try to do a binary search into the second part. That is very simple and straight, and in that case, also your time complexity will be log n itself. Once you do this, and first I'll encourage you to do this way. Once you have
Okay.
done this, then take a challenge that instead of writing the two binary search, can I manage it in a single loop? Can I do in a single binary search? And in that itself, I decide based on the condition whether I have to go and search in this or I have to go and search into this. Okay. Try to follow that lines, and I
Yeah.
think
Yeah. I got it. Yes.
cool. Then the third question is, given a sorted and rotated array, find if there is a pair with a given sum. Okay. Now this question is slight variation of the another question, right? So if you remember, we also talked about the two pointer approach, right? The two pointer approach. What happens in a two pointer approach? Given an array, you have to say that whether the two elements of that array will add it together to give it to a required sum. This is the condition of a two pointer sum, right? And how I told you to solve is that you first sort it, and once you have sorted it, keep one pointer in the start and keep one pointer in the end, right? And then proceed to find that same thing. In this problem, the question is not sorted, but we have additional information that it was initially sorted and then rotated unknown number of times, right? Can we think on a similar lines and try to solve the same problem with the same concept using the two pointer approach? Anybody who has solved this problem, question number 3? Paritosh, Vivek, have you guys tried this question or you have not tried it yet?
Yeah, I didn't try this, but
Please do it. So what I'll encourage you guys, please do solve problems. Please do solve problems. Because unless until you guys solve problem, it will not stay. So whatever theory that we are studying, it's all fine and good, but it will not stick into your mind for a long period of time. Okay? Over a period of time, when the course stops and you guys will stop again attending the classes, a time will come and again everything will go away. The only way to retain this for a long period of time is the practice. Please do it. And what I make sure whenever I give you any problem is that if you solve one problem, this will have some concept which will help you to solve other problems as well. Okay. So that is how I have given you the problem. So don't consider this problem as just a practice problem, but these all problems have some concept inside it, okay, which will help you to solve other problems as well. So I'll encourage, please do it because it's very important. And I think you guys are at that phase of your career where this is like you have to do it. There is no, if you have to mark, have to mark a good job, you have to get a good job, you have to be a good into this. There's no replacement of the data structures and algorithms. So please do it as much as possible. So I want you to make the best out of it. Try to work out as much. I know that sometimes it's tricky. The situation is not favorable. You might have hundred of things to do in the office, but said that try to stretch a little. If for a few next few days, for next 1 month, if you don't sleep enough, you will not die. Take my words. Okay, you will still survive. You have survived so far. You will again survive it. But if you take an extra effort and complete all the assignment and all the tasks, trust me, you will find a totally different you. You will find a different person in yourself. Your aptitude and attitude to solving a problem will change. So I'll again, request you guys to try to solve as much problem as possible because that is the only way through. Right. Now coming to the fourth question, this is a simple question. So basically, you have to iterate, rotate it in all the possible ways and try to find the sum, right? And how do we rotate it? We have already seen one algorithm to rotate in a linear time complexity. So please go ahead and do this. So this is a simple question.